So Kubernetes is kind of a popular platform for container application orchestration. And OpenShift is Red Hat's distribution or Red Hat's version of Kubernetes. And in this part, I will start by talking about something what we call Project Strimzi, which is our project for running Apache Kafka on Kubernetes and OpenShift. And in the second part, I will start by briefly explaining what this Project Strimzi does. It kind of expects a basic idea about how Kubernetes work, but not that much. After that, I will kind of use that to show a demo about more how Kafka works, how you can use it, and so on. So it will be not only slides, it will be terminal, IntelliJ, and so on. So if you will have problems reading the text on the screen, just let me know to try to increase it. So as I said, Strimzi is our project for running Kafka on Kubernetes and OpenShift. It is open source and it basically provides free things. It provides Docker images for running Apache Kafka and Apache Zookeeper. It provides some templates for deploying Apache Kafka on Kubernetes and on OpenShift. And mainly it provides the tooling for managing and configuring Apache Kafka clusters. So if you would want to know some more details, there is a website which we have where you can find the documentation and so on. There are also we have some mailing list, we have some IRC channel, we have GitHub, we have Twitter and so on. So you can follow us there. But if you are interested, of course. But basically the Strimzi project provides a component which is called cluster controller, which is running inside of the Kubernetes OpenShift cluster. And it is responsible for deploying and for managing the Kafka and the Zookeeper clusters. And we are using config maps as the kind of way how the user creates and configures the cluster. So I will now skip to the other window where I have my local OpenShift running, and I will log in. And right now there's nothing running inside. So what I have to do first is to deploy this cluster controller application into the cluster. So that's just a bunch of YAML files which will make the cluster work. So now it should appear there and get running. And once this is running, I can use config maps to deploy the Kafka cluster. So basically the cluster description is, let's try to switch. Yeah, that's better to read. So this is kind of a config map which describes the cluster. It says the cluster name should be my cluster. It says it should have 3 Kafka nodes and 3 Zookeeper nodes. And then it sets a bunch of other options for how the Kafka cluster should be configured. And then when I create this, this config map, the cluster controller will see that and will start creating the Kafka and Zookeeper cluster. So it first starts by creating the Zookeeper, and because I run it really as a live demo and I run it on my local computer, let's hope it will work fine. But it will probably need to take some time to download the images and so on. So in the meantime, we can get back to the slides. So what the cluster controller does, it's really a simple Java application which connects to the Kubernetes or OpenShift APIs. and it's reading it's basically monitoring for the config maps. And if you create the config map describing the cluster, it will start creating the cluster. To run something like Kafka or Zookeeper in Kubernetes, it's not completely easy and trivial. To be honest, Kubernetes are in general not yet as perfect for running stateful workloads like messaging or databases as they are for stateless workloads, but it can be done, and that's why we are doing it. And we are using something called stateful sets for deploying the clusters, which give each kind of member of the cluster a stable identity and allow us to manage it. The Strimzi project is kind of in a early stage, so to say. So there's a lot of things which we are still yet to implement. There's a lot of remaining work around security, like setting up encryption and authentication. There is some work which we need to do to make the Kafka cluster accessible outside of the OpenShift cluster. There is some work to do on auto balancing to make sure that the topics and partitions are distributed in this cluster kind of equally and do not put all the load onto one of the nodes and so on. So the cluster controller is one of the components. Let's check if the cluster is already running. Error, that's not what I wanted to hear. Maybe it will fix itself. Let's see. Another component of the Strimzi project is something what we call topic controller. So once the cluster is running, maybe you will be interested in using the same approach to also manage the topics and the configuration of the topics inside the cluster. So the principle is again the same. So we will create some config map describing the topic, and the topic controller will automatically for you create the topic with the configuration inside the Kafka cluster. Or it works also the other way. If you create the topic inside the Kafka cluster, the topic controller can kind of make sure that it's represented as a config map within your Kubernetes and OpenShift cluster. And there's kind of a special algorithm which does the bidirectional synchronization and the diffing if some changes are done on both sides in the config map as well as in Kafka and so on. Let's see how the deployment is looking now. So we have some things running.
Jakub, while it's loading, can I have a question?
Yeah, sure.
OpenShift is not open source.
OpenShift is open source. There is something what's called OpenShift Origin, which you can kind of download. So that's on basically everything Red Hat does is open source. And on this OpenShift.org, you can kind of download the open source version of the OpenShift platform. And ultimately, that's what I'm actually using for the demo. And then on the okay, let's do it here. On the OpenShift.com, there's kind of more information about the commercial version of the OpenShift platform, which you can then get the support for and so on. But basically, the features of both are pretty much exactly the same. The support is the differentiator.
And the license is GPL or MIT or DSD, do you know?
Now you got me a bit. I would need to check it.
Oh, okay.
My guess is that the license will be something like Apache license 2.0 or something like that.
Okay, yeah, right, that's fine.
Yeah, Apache license 2.0.
Yes, perfect.
So
Thank
it should be quite friendly.
Yeah, it's
Okay, this cluster is unfortunately still not running. And this is actually not because of the Strimzi application. That's because the local OpenShift version doesn't work that well sometimes. So maybe the easiest way how to get it running would be to take everything down. So on the, if you want to try OpenShift, on the OpenShift.org site, you can download the OC client, and then by typing the command OC cluster up, you can, if you have a Linux or basically if you have everything where you can run Docker, this OC cluster up command can start a very simple OpenShift cluster directly in your on your PC, or as an alternative, you can use there is a project called Minishift, which gives you a virtual machine running OpenShift origin inside. So now I started the cluster. I logged in as an admin. Now I have to again install the cluster controller and deploy the Kafka cluster. And let's hope it will work slightly better this time.
And I saw Jenkins icons. Does it mean that I can use, for example, OpenShift cluster as a source of the Jenkins slaves?
You can run Jenkins on there. Actually, kind of, it has the, so one of the differences between Kubernetes and OpenShift is that OpenShift has kind of its own Jenkins-based CI built into the system. So, and I will actually use it in the demo later, but you can set up some builds and some pipelines directly in OpenShift, or you can deploy Jenkins on top of it. And then, but that's kind of not OpenShift exclusive. There are some plugins for Jenkins which allow it to run on a Kubernetes cluster and basically use that as a slave for running the builds and so on in pods.
Time for a thing. Yes, right.
So back to the slides before it hopefully starts. For the topic controller, we do a freeway diff to make sure, because one of the problems with Kafka is that Kafka does create a lot of the topics on its own. And therefore, you can't kind of manage the Kafka topics only from the Kafka, because as we will see, for example, with the Streams application or with the Kafka Connect framework, they create a lot of help topics inside. because a lot of the Kafka components are using Kafka to store the configuration and things like that inside Kafka. So that's why we have this three-way diff, which is able to reconcile all the changes and give you the view of the Kafka topics both from Kubernetes as well as from the Kafka itself. So the topic controller basically reads the information and then use Zookeeper as its own information storage to make sure that all these informations are diffed properly. And yeah, we have also some further development plans here as well. One of the challenges here is that the names of the Kafka topics are using different syntax restrictions than the Kubernetes resources. So it's not always easy to map these against each other, but that's what we need to deal with. We also want to use some aggregated API server and other things to make it work a bit better. So in the meantime, the Zookeeper cluster started and all the nodes are running, and the Kafka cluster is also starting. So one of the other things which we need to deploy is the Kafka Connect framework, which I talked about in the previous part of my talk. And the demo which I will show will basically use a Kafka Connect plugin to connect to Twitter and read information from, read tweets from Twitter. And then we will use the Kafka clients and the Kafka Streams library to analyze the tweets and somehow process them. So the things I need to do next is to deploy the Kafka Connect cluster. And the deployment is again done using using a Kubernetes config map, which says that I want to deploy Kafka Connect, and I want to run it with some specific configuration. So I will now deploy it into the cluster. So again, once I create the config map, controller will automatically take it and start deploying the Kafka Connect. And the controller also deployed the topic controller, which I will use to manage the topics. In the installation that by default, the Kafka Connect doesn't have inside any plugins or anything like that, apart from these two basic for reading file, writing to a file. So in order to connect it with Twitter, I need to add the plugin to it. I have the plugin downloaded locally. It's basically a fat jar file with all the dependencies. And it's coming from this project on GitHub, which has it as an open source Kafka Connect plugin available. And I will use, so I mentioned the build system for OpenShift, and I will use that to add these plugins to the Kafka Connect deployment. So what I will do for that is I will start a new OpenShift build where I would say, okay, take this my connect cluster and add to it the jar files from the dir Kafka Connect plugins, which is the dir where I have this jar file. Now I press enter. It will upload the new jar file into the OpenShift cluster. Here you can see that the build number 2 is now running. So that will take the plugins, the plugin for build automatically a new Docker image with that. And now it will start the new container and rolling update from the older version which didn't contain the plugin to the new version which contains the plugin. And I can go and somewhere here we should see that the plugins are. I now can't find it in the long log, but the plugin has been loaded and should be available there now. So another which I will do now is for the demo I will show, I need to use some Kafka topics, and I will create them using the topic controller through the config maps. So this is an example of how the topic configuration looks like. So it basically says that the name of the topic should be Twitter feed. It should have 10 different partitions, and it should have 3 replicas for each partition. And here it configures that the partitions should contain up to 256 megabytes, so that it doesn't fill my disk with tweets. And in this topics directory, I have more of these topics there, and I will now load all of them into OpenShift. And the topic controller will do the work for me and create the topics in Kafka. So what I can use this OpenShift console for is to remotely open a terminal in one of the Kafka pods. And I can run there one of the Kafka management commands, which is a utility called Kafka, which will list all of the topics which exist in the cluster. And here you can see the topics created through the config maps. So this is the one which I was showing. So basically, a utility like this lists for every topic the name. Then it says that it has 10 partitions. That the replication factor is 3 and that here is some special configuration. And then it lists, and here you can see the information that the leader for this partition is on the broker number 1. The leader for the second partition is on broker number 2. The leader for the second partition is on the broker number 0, and so on. And here you can see the list of where all the replicas are. And then this ESR column says that all of these replicas are currently in. So here you can basically see all the things which we discussed in the previous slide deck about the leaders for the partitions and the replication and the in-scene replicas and so on. Now the topics exist. Everything seems to be running. So I can now create the Kafka Connect plugin, kind of configure the Kafka Connect plugin to connect to Twitter. And so the Kafka Connect framework has a REST interface, which can be used to configure and instantiate the plugins. And the only difference between this file and the file which I will actually use to in the curl command to create the connector is that here you have to fill in all the Twitter secrets and so on. If you want to try it on your own, it's quite easy. You just go to developers.twitter.com or something like that. You register there as a developer, and you can then connect to their APIs. And I'm not sure how many of you are football fans. I am a football fan, and I support a team which is called Aston Villa in UK. And here in this track terms field, I have several kind of keywords, which I will use to the Twitter API to give me all tweets around this topic. And now I will just use a regular curl command to create an instance of the connector. And I have to send it to the Kafka Connect IP address. So that was successful, and now I can use another command to check that the plugin is running. So I can now see that I have an instance of my of the Twitter plugin called Twitter Feed, and that it's running on the worker node with some IP address. So the Kafka Connect framework can run as a cluster with multiple nodes, and it can kind of load balance and fail over the plugins to make sure they are running and they are properly distributed and so on. And now one of the other useful command line tools in Kafka is a tool called console consumer, and I will use that to see whether I'm already receiving some leads from Twitter. And hopefully get something. You can do the same by writing your own client code. So let's move to the wrong window. So this is how a Java-based Kafka consumer looks like. It's a simple application. So here on the beginning, I use some properties where I configure the informations about the server, like the IP address of the Bootstrap server. Here I configure the group ID, which will allow my consumer to be part of some group. Here I configure some timeouts. This is the important part where I configure the classes for deserializing the data. So remember I said that everything in Kafka is byte array, but we do not really want to read everything as a byte array. In this case, I know the messages I receive are sent as strings. So I can use these string deserializer classes to, which will automatically convert the byte arrays to strings. And then really simple, I create the Kafka consumer using the properties which I just configured here. And I use this string template to tell the Kafka consumer that I want the key and the value of the message to be automatically converted to strings. So if the message would be in some other format, you can, for example, you have the, I don't know, the key as a long, you would just have a long here. And once I create the consumer, I subscribe the consumer to one or more topics. So in my case, it will be only one topic. And then I just run in a single while loop where I'm polling the consumer for the messages. And here you can see kind of how the batching works in the Kafka broker. So the result of the poll, which basically does the fetch on the Kafka server, it's not a single record, but it's always a set of records. Yeah, so that's why it's called records. And then I have to iterate over this records field to get the individual record, the individual message, and I just print this individual message to the command line. So let's see if we run it. I think I need to increase the font here. So here you can already see the tweets arriving to the application. And I'm getting them in the default Twitter format, which is kind of a JSON thing, which looks like this. So there is information. There's some information about the user who published the tweet. There is the text of the tweet as well. There is information about language. There is a list of hashtags which were included in the tweet. There is a list of pictures or videos which were in the tweet. There is a list of URLs which were in there. And there's also a list of users which were mentioned. So there's a lot of data inside, and they are all kind of structured in the JSON field. So now let's say, and that's where we get to the Kafka streams. Let's say I don't like the format like this, and I want to have it in a much easier format where the Twitter username of the user will be the key of the message, and the text of the message will be the body of the message. Yeah? And for that, I'm using Kafka streams. So this is example of Kafka Streams application, which is using very simple transformation. So again, I have to change the IP address to the correct IP address. And so in the Streams application, I set some application ID, which in my case, I named Transformer. Then I specify the Bootstrap server in the same way as I did for the clients, because if you remember the Kafka Streams, it's really just packaging around the Kafka consumer and Kafka producer. And then I use this Streams builder to build the stream application. And basically, I just say the builder to create a stream, which will read the data from the Twitter feed, which is where we are getting all the Twitter messages. And it tells the stream that the format of these messages is string as the key. And now for decoding of the payload, I will not use string. Instead, I here on the beginning created some deserializers and serializers using JSON. So what I will get here is I will get the message automatically decoded as a JSON node. It's using in the background, it's using the Jackson XML library from faster XML. And it will not give me the message as the string anymore, but it will give me the message as a JSON values. And now on the next line, I simply say that I want to remap the key and the values of the message. And here I basically say that the key should be from the JSON. I want to take the field user, then the user screen name, and then interpret it as a text. So if I go back to the JSON string, this would basically give me this thing, the content of the Twitter username. And then as a value, I want to use the content of the field as a string. So that gives me exactly this field. And then I do one more transformation. but this time I transform only the payload value and not the key. So I take the value, which is now only the text field, and because some of the texts have line separators, and for whatever reason I don't want there to be any line breaks, I just replace all line separators with empty string to get rid of them. And now this is really the streams is just a library, nothing else. So I can just run it as any other Java application.
Excuse me.
And,
Can I interrupt you for a second? We have a Marco on our stream
yeah,
that
sure.
I can't mute him, but he's making.
Okay, sorry.
Can you mute yourself, please?
Just a moment to see. Am I muted?
No.
No, just a moment.
Mute yourself in the.
Okay, sorry.
Yes. Yeah. Fine. Thank you very much. Yeah. Please, Jakub, go on.
So now we have the streams application running and processing the messages. So now I can go to a console and see. So if I go back to the code, what you can see in the code is that once all these transformations, the output is sent to another topic, which is called tweets. So now I will just go to the console and see what I can read from the topic tweets. And as you can see now, the old messages, which were all these ugly JSON things, are now transformed. The key is always the name of the Twitter user, and then there's a simply text message with the tweet itself. And so basically within 6 lines of code plus some settings, I completely transform the data. And the Kafka streams, they can be scaled. I can run that in multiple instances if I want, and so on. So really with a very lot of effort, I did quite a lot of work. But it's just a simple transformation, so that's nothing complicated, really. So, let's see if we can do something better, something more stateful. So I have another example using Kafka streams, which will do something similar. It will create a stream from the Twitter feed. It will again decode the payload automatically as a JSON. Then the transformation I did in the previous example was really just a simple, where I took a single message and transformed it into another message. But what if I want to kind of flatten the structure in the payload, and maybe from a single message I want to create 5 another messages? So that's what this flat map values can be used for, where basically I use a function here, but out of the JSON, I basically take this hashtags array and transform the messages from one message containing the whole tweet into one message containing a single hashtag. So if the message would have multiple hashtags, then each of these hashtags will get its own message. And that's what this flat map values does, where here basically I read the hashtags values as a text and return them as a iterable, as a list or something like that. And then the Kafka streams will automatically transform that every field of this iterable will get its own message. And then because the hashtags are kind of case insensitive, I would additionally do just the regular transformation where I change everything to lowercase. So that's not different from the previous example, but now it starts getting different. So now I will start something called K-table, which basically does a stateful operation. So the Kafka streams operation, stream application will create a stateful storage. So it will use locally RocksDB database from Facebook for caching, but in the background, everything in this table will be properly stored in a Kafka topic. So if this application restarts or if you run multiple of them in parallel, they can share the state and they can keep the state persisted in the Kafka database. And what I do here is I will now group all the messages with the hashtags based on the value. So the value now is just the hashtag itself, and I will do a counting of them. So every time this produces a message with a hashtag, counter in this database will be increased for a given hashtag, and I will be able to kind of over the time see how much was where the different tags used in the Twitter feed which I'm following. And then I will again just take this table and push it into a stream, into a topic called Twitter hashtag counter. And this time the formatting will be kind of, the key will be a string, and that will be the name of the hashtag. And then the body will be just long, saying the count, how many times it was mentioned. So when I now run it, it should start processing the tweets, and let's increase it. So the lock of the streams application is not that interesting. This part is kind of interesting because it, for example, says that because I run only one instance of this application, that everything, all partitions will be consumed by this instance of the application. And then this is the interesting thing, where this is basically the rebalancing process which I was talking about, where it starts with all partitions being kind of removed from the applications. Then the group lead assigns the partitions. Here we can basically see the result of the partition assignment. And then it transitions from rebalancing to running and starts actually reading and processing the messages. And when I go now back to this console, so this Kafka console consumer is what I will be using again. And I will just read this Twitter hashtag counter topic. And you can see I immediately get the list of all the hashtags which were mentioned in the tweets since the beginning, since we started the demo, and the number with how often they repeat it. And every time there's a new tweet which arrives, it will be, the counters will be increased based on the hashtags which were there, and they will increment, and then they will be published to this topic. So you can see there that it now does some stateful transformation, and it keeps the numbers and so on. So now new tweet arrived, which probably had these two things. So the numbers were increased and they were sent again. And when I list again the topics which are in the cluster, you can see that it created yeah, you can see that there are these new streams created. This hashtag counter case stream aggregate state store changelog, which is basically the topic which the Kafka Streams application is using to persist the stateful table with the counts into, so that if I stop and start the application now again, the numbers which it calculated already are not lost. So that's one example of what you can do. A slightly more advanced example is using windowing. So the hashtag counter example is basically just counting the text from the beginning. But maybe that's not that interesting information, because maybe the application is running for a few months, and on the beginning someone was using a lot some tag, but it's not using this tag anymore, but it's still kind of high in the ranking, because that's it got in the beginning. So maybe I'm interested more in what tags were used in the last 1 minute, in the last day, or something like that. And for that, I can use something what's called windowing. So in this example, everything is pretty much the same as in the original one. But here I say something called window by when I create the stateful table. And I set the window in this case to 60 seconds. And it basically means that this table will not be counting the occurrences of the hashtags from the beginning of the demo, which we started, but instead it will be counting how many times this thing occurred in the last 60 seconds. And then again, I will take this data and produce them into another topic. And it should just show the occurrences in the last 1 minute. Oh, and it will not work because I didn't change the IP address. So I have to change that. So this is now running again, and I will go back to the console and read from the new topic. And now wait some time because it first has to collect the information before it prints it. But once some new tweets arrive, it should give us the information which we want. Yeah, the encoding is a bit messed up because the key isn't anymore only the hashtag, but you can see that it's producing some counts. And so to be honest, these examples were fairly stupid and not that useful. I hope they kind of demonstrate what you can do using the Kafka Streams library. And it can do even more. It can, for example, do some joins between different topics, and it can really use the Kafka as a database more than as a messaging system. And it can be really useful for processing the data. There's even a framework which is called KSQL, as in Kafka SQL, which allows you to do similar operations with the SQL syntax. So that can be even easier to write for some data engineers and analysts and so on, and you do not necessarily need some sophisticated programming skills to do a lot of stuff. So ultimately, all of these applications, you would be able to write them using the regular consumer and producer, but it would kind of be not as easy and as fast to do as with the Kafka Streams library. And that's pretty much it for the second part. Any questions?
No. Yes, we have a question.
You mentioned about QSQL. Can you please describe what's the difference between ANSI SQL and QSQL?
So the KSQL has kind of, it tries to follow the ANSI SQL syntax, but it basically operates on top of the topics. Yeah. So allows you to basically write Kafka clients using using SQL syntax. So I'm quite sure there will be. I'm sorry, I don't have any exact examples for that, but these are basically the examples. So in this example, you basically create a table based on the topic called monitoring stream. You create a table which is doing some counts in case there is some error type message. And similarly to my example, it's using the windowing for 1 minute. So this will be basically producing a table which will be stored and represented in Kafka, but it will basically track the number of different error code occurrences from some log collecting stream, and push that again back to Kafka, where it can be, for example, consumed by another application which will call some pager when the error code, where the count for, I don't know, HTTP 404 is for the last minute bigger than 100, then page some operator or something like that. So it's kind of using the SQL syntax. I'm not exactly sure how much it follows the ANSI standards because it doesn't really work against the real SQL database, but the idea is that the syntax should be as similar as possible.
Cool, thanks.
Any other question? Other questions? No. I have a question, little slightly unrelated, but you started all of this on the OpenShift, which is kind of sort of the Kubernetes, and I'm interested. Is this with Kafka? Does it have any like features? Like it's actually monitoring the load on the broker and try to increase number of partitions or number of consumers.
So
that's
yeah. So it doesn't automatically do this for you, Kafka itself, but for the number of partitions, even that isn't done automatically, because if you increase the partitions of existing topic, you remember every key defines into which partition the message goes. And now if you start it and you run your application for some time with, I don't know, 100 partitions, that means that if the message key was, I don't know, some customer username Jakub Scholz, then the producer calculates the hash, and the hash will say, okay, this message should go into the partition 90. And now suddenly, if you increase the partition count to 200 instead of 100, the hashing will work differently. Yeah? So now it really works as a hash table. So if you now run the hash of the username Jakub Scholz, which would be the key, it might say, okay, this message should go into the partition 150. So if you change the partitions from a running application, it can actually kind of cause data inconsistencies, because now anymore you will have not the guarantee that all messages with the single key will be in partition. Some old messages before the partition increase will be in the old partition, and the new messages will go into the new partition. So that's why it's not possible to really do these things automatically. And so that kind of goes a bit back to what I said about the bigger need for the architecture design before we actually start using it. Because if you kind of misjudge the number of topics, then it's not necessarily easy to change the number of partitions afterwards when the application is running, because it would basically kind of mess up with the data with a single key being only with a single partition. So that's why I'm not aware of any system which would, for example, automatically increase the partitions. What the tools for cluster balancing are doing, so I try to slide. So this one, for example. So the tools for cluster balancing, what they can do automatically is imagine a situation like this, but for some reason the partition 1 on the topic 1 is a real busy one, and the partition 2 on the topic 2 is also a real busy one. Whereas these two partitions, they are kind of idle, not doing that much. Yeah? So that means that this broker will be under quite heavy load, whereas these two brokers, they will be not that busy. And what the cluster balancers are doing is that they are monitoring the broker nodes, collecting the informations like disk usage, number of partitions, number of clients, network utilization, and so on. And they example decide that maybe you should move this partition from this node to this node to make sure it's are kind of more equally balanced. But kind of on the automatic level, it will do just this and nothing more. So the partition changes and so on, that has to be done kind of always by you.
Okay, yeah. And this cluster balancing tools, what are those? Is this built in Kafka?
No, that's not built in Kafka. Let me find the right projects.
Ah, okay. Sorry.
There are several of them. There are several of such tools. So Confluent has one of them. So here's, for example, another one which kind of will be used to do the partition balancing. So you just run it against the cluster, and it will take care of all the things. And so this one is another one, but I'm not sure whether the Confluent one is actually open source. I think it's most source is available only to the Confluent customers, but you can kind of see here the idea of how it moves the topics and partitions around. And I'm quite sure LinkedIn, here exactly this cruise. So the cruise control, that's another tool which is used and open source by LinkedIn directly. It again does the same thing. So I think there are around at least 10 different projects for this.
Right.
As far as I know, the cruise control is fairly valued and used quite often.
Okay. I don't have any questions. Maybe remote people have questions. Looks like no. Well, I think then that's all. If you don't have anything else to present, yeah, I think.
No, from my side, this is it. Yeah.
I think it was great, two presentations. I learned a lot. Yeah, so any other words from that?
No, thank you.
Yeah.
Thanks.
Yeah, thank you very much then. Yeah, and I think we can then end our remote session after it. Mostly we didn't have the third speaker